what it is you have stumbled in upon.
Welcome to another episode of Astronomy Cast. Let me just get my pop-out chat rolling so I can actually see what people are talking about. Okay, I'm ready. So last night, we did the episodes of Astronomy Cast, and we talked about the video games, and I was like, after talking about that, I got so excited that I just like immediately picked up the Steam Deck and played all night. Like,
That is that is
yeah,
absolutely wild and
yeah.
awesome, and I deeply,
Yeah.
deeply appreciate it. And I'm
Yeah, it's so
trying.
funny. We're sitting there talking, and in the end, I'm going like, "Oh my God, I really want to play all these games." And so I just sat down and played RimWorld, of course, for a couple of hours. I've been playing all day today as well. I don't have a problem.
No, no problem at all. None.
Yeah, yeah. But that was great. That was a lot of fun to sort of get other people's perspectives on what are their favorite video games, and there's a couple there that I haven't played, which is great.
Yeah, and I'm really looking forward to moving past doing fundraising and finding a little bit of spare time that I can abuse for the pursuit of video games. So,
Yeah.
have you ever had to have surgery or be on powerful medications because you were really sick?
Hmm.
So, when I had my gallbladder removed a couple weeks ago, I had every intention of
Right.
sitting down and playing the brand new Zelda game because I knew I wasn't good for anything else.
Yeah.
But one of the folks that I've worked with, Tiny Intern, just as I'm sitting down getting ready to download everything, was like, "Oh my goodness, there's this great new game, Disney Dreamlike Adventure. It's just like Animal Crossing. It's fabulous." And I had the spare money to buy either Zelda
Mm.
or Disney Dreamlight, whatever it is. And I accidentally made the right choice for every single possible wrong reason. Because I bought the Disney game thinking, oh, it's like Animal Crossing. I missed this part of my life. Now, the thing is, this is a game that is nothing but the grind of a video game. You are
Mm.
always trying to just like complete some task, and there's essentially no problem solving and no way to screw up, and nothing evil happens.
Right. For
There,
kids.
right.
Hmm.
And the healthier I got and the better I got, the more I realized how much I hated this game I had just dropped a large sum of money on. And so I felt no desire to just stay in bed playing this
Mm.
video game any longer than absolutely necessary.
But you own a Steam Deck, right?
I do.
Okay, and you bought a physical video game, or I guess a download on your Switch. This sounds like a
No,
Switch.
no, what? Yeah, it was Switch, wasn't it?
Yeah.
So I have both my Switch and my Steam Deck plugged into the same large monitor, and I can just switch between which one I'm looking at.
See, so this was the conversation we were having last night, which is
Mm-hmm.
for me anyway, because I spend all this time in front of a computer screen.
Mm-hmm.
I was sick of sitting in front of the screen for any second longer to play any video games. And what was the what sort of restored my enjoyment of video games was the Steam Deck, that I could lay back on the couch with the game in my hand. Carla could be like working on a photograph, and I could just be lying in bed beside her and playing on the Steam Deck. And so because it's like a different place, it really rejuvenated my interest in playing video games again, because I'm so sick
So,
of sitting in front of a computer screen.
so I hear what you're saying, but I had just had my gut
No,
cut
I understand that.
into,
Yeah,
and
yeah.
my computer monitor that I was using was not associated with a desk. It is on a arm that
Right.
attaches into my windowsill. So I was on a daybed with an arm swung out and a monitor here.
That does sound pretty
with
civilized.
nothing. It's glorious. It's glorious in every way. There is no desk involved.
Right. No keyboard, no mouse.
So I can use a mouse because sometimes it's just easier to like interact with keyboards and shit when you have the on-screen ones. But it's on the windowsill too. So I'm like lying parallel to the window and arm on chair and arm on chair arm, and if I need to, I click over on the windowsill, and it's glorious.
Yeah, that sounds pretty good. I'm I've got my reading glasses so I can see on my tiny little screen. So anyway, we should do our job.
We should. All right. So we are here to record another episode of Astronomy Cast. I see we have Zaps fan. There are people apparently waiting in the wrong place, but we're in the right place. So, all right.
Where are they?
I
they
don't
on YouTube?
know. I don't know. I mean, they're probably in our YouTube channel, yeah. So I couldn't figure out how to go out to two different YouTube feeds at the same time.
Oh, what? So you're streaming this on the CosmoQuest YouTube feed?
Yeah.
Right. So this is on CosmoQuest, right?
Yeah.
Okay.
So Zap fan, thank you for figuring out where we are. I deeply appreciate it. I will copy this over to the Astronomy Cast channel. If you can copy the link to this over to the Astronomy Cast chat right now, I heart you. So we're doing this during the Hangout-a-Thon. We are trying to raise funding to support CosmoQuest because the economy is not good right now. Donations are down, bills are up, and I'm trying to keep the parts of the staff that don't work only for Astronomy Cast funded. So you guys are doing good supporting Astronomy Cast. Heart you. Thank you. It's Escape Velocity Space News, Vision Cosmica, 365 Days of Astronomy, all of those programs. We are sitting at numbers. I'm just going to remove off the screen. Thank you, Sleeper Sai, for gifting a whole bunch of Tier 1 subs. Thank you so very, very much. Thank you so very, very much. I'm going to do this episode utterly undistracted by donation amounts. That is pleasing. All right, so
that should work.
Are you going out to the Astronomy Cast?
I'm not going to Astronomy Cast, but I just gave them the link.
Okay, cool.
But we should cancel this episode.
I am afraid to touch anything on my computer.
Yeah. Because people are waiting for it. Okay. All right. I'm going to switch over to Astronomy Cast, shut that one down. I think.
And later
I don't know if I'm doing this right, but what's the worst that could happen? There's 7 people waiting. So
okay.
I will. I see. And the other one was people were waiting for 2. So I'm going to delete them.
Okay.
Right?
Yes.
Or make them private. That way, at least we don't lose anything. Okay.
And we will be recording an episode of Escape Velocity Space News later today. Up next is going to be There's More Than Hydrogen and Helium. Let's Talk Rocks. We're going to be joined by Rocket Sage and Gordon Dewis, our own keeper of maps. Coming at 6 p.m. Eastern is going to be Mars Had Water, but not when Percy, as in Percy Lowell, had thought. We're doing Meet the Staff with Aviva Yamani at 7 p.m. Eastern, and we are recording Escape Velocity Space News live at 8 p.m. Eastern. And
Escape Velocity Spoos?
Space News. It's related to a moose, I guess, at least how I pronounce it. It's a busy day, and I'm glad that all of you out there for this live recording are part of it. But this session, we are recording next week's Astronomy Cast because Fraser has grand adventures in his future. And we're going to let him do those grand adventures without attempting to do any recording while traveling because we've done that for enough years and the technology will never be ready for it.
No. So the thing that we're doing this time around is we're going to be taking Starlink and we're going to get the Roam package with Starlink. So it's a little bit more money, but it lets you go anywhere and use Starlink. And so in theory, wherever we go we're going to the US, I will be able to have a high-speed internet connection if I can reach space. If space is above my head, I will be able to high-speed internet. And we can run the Starlink off of our vehicle. So we can plug in the truck, plug the truck kind of acts like a generator.
Yeah.
And we can plug in, it has a plug inside of it. And I can plug the Starlink into it and it puts out enough to run the Starlink. And so we can just stop the truck at the side of the road, put the Starlink on top of the truck, plug it in, leave the truck running for half an hour and use the internet if something is absolutely urgent. So
I love the state of communications we're at.
Yeah.
It's excellent. It's excellent.
Well, and you know that the inevitable future is that your portable device will have a high-speed connection to the internet anywhere on Earth through some kind of satellite connection. Like that is the final state of this whole process. And I think about this conversation. I was traveling with my kids and we didn't, you couldn't get high-speed internet over the cell phone. We had to get Wi-Fi and I didn't have a cell phone. It was like 10 years ago. I didn't have a cell phone with me. And we were traveling in the US and we were searching for Wi-Fi. And I was telling my kids, like, there's going to be a time in the future when this seems hilarious that dad needed to find random McDonald's, park in their parking lots, try to get Wi-Fi long enough to be able to deliver a story. It's
just going to be a very bright future because, like, currently Blue Walker 3 is a prototype of one of the networks devised to do from space cellular phone connections. It's running on 3G. And this is a satellite that has a similar footprint to a small house and is like 100% highly reflective solar panel. It is somewhere between 0th and 1st magnitude. It's bright.
It's the 6th brightest star in the sky.
Yeah.
So no, thank you. I mean, Starlinks, at least they're magnitude 7. Like you can't see them with your eyes. You can only see them in a telescope.
Yeah, and they don't go straight to your cell phone. They require something a bit bigger and more sensitive. And that's why they can be fainter. Just this less power means less area needed to collect the power needed.
Yep.
But this isn't our episode.
No. Maybe that's a separate episode. How to get internet in this day and age. Nope. Let me know when you're ready.
All right. I am looking for.
Did you get that message I sent you?
Yes.
I sent you a document.
I have it open.
At all?
Yes.
Okay.
All right. I am opening. I have already opened. I am lying. I'm evicting the dog. I'm doing that first. One moment. Someone let a dog in here and it wants out.
Not the Brain says apparently Starlink uses a lot of power. Yeah, it uses about 100 watts of energy. And so you can't just plug it into a small battery pack. Like you've got to plug it into something that is electricity. And so when we were first building but before we even had electricity on our property and we would come up and stay the weekend, we would turn on the truck, plug in the Starlink, run it for 10 minutes, upload and download everything that we needed, make sure we had all of our shows from Netflix and checked all our email and all that. And then we would shut the truck off and then we wouldn't have the Starlink again until the next time we decided to turn it back on and off. So it's better with my electric car because I could plug in my electric car down in the city and then I could plug in the Starlink into the electric car. And then it would use up about 5% of the electric car's power per hour. on the 100 watts. So in theory, I could run Starlink for 20 hours on my electric car. And I have like an old Leaf. So, Zephan, no, there is not an episode of Astronomy Cast tomorrow or
Correct.
next Monday.
Tomorrow so I can sleep, and next week so Fraser can have adventures.
Yes.
These are both worthy and noble causes.
Yeah. I do think I'm going to do a double episode of my question show tomorrow just to give me more room to breathe. So,
Yeah.
so be prepared for that. And on Monday, I'm going to do a double episode of the question show.
All right. So I am pressing. I'm first making sure it's using the right microphone. Yes. All right. So I'm pressing record on the audio.
I have also pressed record.
I have pressed record on the video. We are ready to talk science.
All right. Astronomy Cast, episode 698, New Insights into the Universe. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain. I'm the publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well enough. We are currently in our, oh dear, we are currently in hour 26 of our 32-hour fundraiser for CosmoQuest, an Astronomy Cast partner. Patreon is down. It's down for Astronomy Cast. It's down for CosmoQuest. Our donations are down. The economy isn't good. A lot of people are worried about war. But the humans that work for us still have bills to pay. And everyone working for Astronomy Cast is okay enough. So we're doing good. We had a cushion. But over on CosmoQuest, we're struggling a bit more. And we had this horrible realization that across everything we do, it's like 1% of the people donate. And we want to give everything away for free. But if everyone who downloaded an episode last week donated $4 once, we'd be good for the entire year. Good.
Yeah.
And so unfortunately with that only about 1% donate, we're here begging. So
Yes.
Hi, if you would like to donate, we'll have all of the links in the discussion over on YouTube, and they're going.
But just in
the
general,
chat.
go to cosmoquestx.org.
CosmoQuest.org.
Cosmoquest.org/donate.
Yeah.
And you can kick a couple of bucks our way. And of course, CosmoQuest provides all kinds of educational services, runs community, and helps with developing citizen science projects. And so all of these are valuable and important, and we pay people salaries to do this work. And so if you want to help us out, please go to cosmoquest.org/donate. How the time flies. It's been over a year since JWST went operational, with other missions joining the fun. What new insights have we gained about the universe thanks to these powerful new tools? And we will talk about it in a second, but it's time for a break. And we're back. Doesn't the time really feel like it's flying? I mean, July 2022 was when we got the first light images from JWST.
Yeah.
And here we are now. We did an episode all about 1 full year of Webb observations. We are now in November, so another 3-4 months on top of that, and science marches on. And I mean, really, we've been getting, like, in the beginning, everyone was kind of excited, and people were getting ahead of over the end of their skis. People were making instant claims that maybe needed a little more research to look into. And so I think this is a great time for us to think more deeply about what we've learned about the universe now that we are this far into the JWST era.
And what I love is, I think the biggest thing that I've walked away from all the JWST papers with is a even stronger feeling that the universe is an improv artist that really likes to say yes and. It seems like every time we've ever had well, it's this or it's this, the answer keeps being both.
Both.
And my favorite example of this was one of the first papers to threaten to revolutionize cosmology was one of the ones that looked at JWST's images of galaxy clusters and deep fields and basically said, there's bigger stuff out there than there should be. There's brighter stuff out there than there should be. Therefore, the universe must be forming bigger, brighter things sooner, faster than we expected. And the follow-up observations have been like, well, some of them aren't where we thought they were. Some of them are doing things different than what our models assumed, so they're actually fine. And yeah, some of these really don't make sense, and I'm loving it.
Right. I mean, for sure, like within days of JWST going live, I was looking through the various papers coming out of both journals as well as all the stuff that's on archive, which is always sort of a bit of a dangerous game, because it's all pre-print. And you were seeing people see galaxies that were like 200 million years after the Big Bang, 230 million years, 170 million years after the Big Bang. And like, that's astonishing. That is so much earlier than Webb. So much earlier than Hubble. And so like, that was exciting. And it was still just like, we think we saw a galaxy. That was the beginning and the end of the paper at that age. But then you got that round of papers saying, what we're seeing, these galaxies are too big, too soon, that every model of our understanding of the cosmology of the universe, none of them predicted this.
And what wasn't mentioned in a lot of the coverage of that discovery was the fact that they based the size of the galaxies on how luminous they appeared at their distance and an assumption of the size distribution of the stars. So like when you look at a galaxy in our modern universe, there's going to be a whole lot of tiny stars, a whole lot of medium-sized stars, but not quite as many. And as you get bigger and bigger along that initial mass function, you get fewer and fewer stars. And so when we see a system that's a specific luminosity, it gives off a certain amount of light, and we measure how bright it appears, and that allows us to figure out how big it actually is based on this assumption of the distribution of masses of the stars.
Yeah, and so as more work was done, as more science was done, as the spectroscopy came in, as people were able to analyze these galaxies in more detail, all of these extreme observations about the galaxies started to go away.
Yeah.
And where we are now, and like, I don't think people know this, that where we are now is that everything is fine. Everything is exciting, but everything is fine.
And my favorite part of this was the mix of how we got there. And I'm just going to keep detailing this out. So it turned out that a couple of the systems being looked at, they had a different distribution of colors than initially assumed. And since we were doing broadband photometry for the images, you get colors but not spectral lines, and you can use that to estimate the distance to an object. But if you don't know correctly what the mix of stars is, you're going to misplace your galaxy. And so a few of the galaxies were just misplaced. And once we got spectra that allowed us to see specific atomic lines, measure the specific distances, those objects got a whole lot closer and a whole lot less suspicious.
Right. Yeah. And that, like, certain kinds of surveys of this early universe told you that, like, were preferential towards making some galaxies look bigger, but not revealing some of the other ones that would have been in the same field of view. And so you were just seeing some of the bigger ones, and that was starting to skew the results. And then the other thing is, a lot of really interesting theories have also been put out, like, for example, well, early on in the universe, star formation probably went in pulses. And so you're seeing something that isn't just the continuous starlight from a giant galaxy. You're seeing one of these galaxies that's going into this flare up of star formation. And the other thing that's been really interesting as well is the interactions between the galaxies. So there's a lot of papers coming out talking about quenching, about how galaxies with active galactic nuclei are blasting out material that is then shutting down star formation in nearby galaxies. And so it's all of these nuanced discoveries that are adding a lot of really interesting texture to the things that astronomers already knew about the early universe. That's the real part that I think you should be focusing on if you're listening to this, that nuance is now being worked out. And that's where the real progress is getting made. You're not overturning the Big Bang. You are discovering how galaxies, when they were smushed together, were interacting with each other to cause mayhem, which is really interesting.
And nuance almost feels like it's too cautious of a word. It's one of these things where we ran computer models that came up with a certain set of results, allowed for a certain set of possibilities, and we as human beings failed to be creative enough to include in all the details that needed included in. And because of that, we simply failed to imagine things that now we look at what the universe is actually doing, and it's like, oh yeah, that's obvious. We should have thought of that. And so our own failure to include all the needed complexity meant that we didn't understand what we saw the first time. But on the second and third glance, it was like, oh yeah, okay, this is cool. We're fine.
I mean, I'll give you one really interesting kind of practical example of this, which is these outflows, that galaxies have these outflows coming from them, as I said, that quench their nearby neighbors and shut down star formation. And so you can have some galaxy that is putting out all of this radiation and all these particles, and then their neighbors are not being able to go through the same amount of star formation. And astronomers weren't sure what was the source of these outflows. Like, one possibility is that it could be supernovae. Another possibility is that it could be mergers, star formation. And then another possibility is that it could be material that's coming out of active galactic nuclei. And that they were able to now, they're fairly certain this is coming from the black holes, from the active galactic nuclei, not the supernova, not the star formation. And that requires resolution. That requires being able to do really good spectroscopy on your galaxies to get a sense of what the source is. And so there are all of these mysteries. If you sat down cosmologists and just said, like, give me your top 20 mysteries at the beginning of the universe, they'll have a bunch of them, and they'll sound like, what is the source of galactic outflows? And Webb is so precise that it is now providing evidence to each one of these mysteries to lead this conversation further. And I think that is just something that's just not making the headlines, which is too bad. And
I think we have to give credit where credit is due. Accretion disks are the real baddies of the universe.
Yeah.
The supermassive black holes are just sitting there going, I'm spinning and I'm big. And this inflowing material is forming a spinning disk that is hot. It has nuclear reactions going on. It's generating extraordinarily powerful magnetic fields that are driving these powerful jets. And the light from these accretion disks moving outwards in some cases can destroy star formation within the galaxy the accretion disk lives in. And the jets popping out have the potential to hit other galaxies and end star formation in them. Right. Don't be afraid of the black holes. Be afraid of those under-acknowledged accretion disks traveling the universe with them.
Yeah. Yeah. And so, again, I'm kind of having trouble putting this to words, but just be patient
Yes.
and enjoy the ride as these mysteries get solved one after the other. Now, we're going to talk about this some more in a second, but it's time for a break. And we're back. So let's get a little closer to home now. And I would say one of the biggest mysteries that is now being solved right in front of our eyes is rogue planets.
Yes.
And Webb gave us one of the most exciting announcements based on this.
The Orion Nebula
Yeah.
is full of star formation. We know this. We love it because of this. It is extremely dense in star formation, and it is apparently a world knock world situation gravitationally, because there are thousands of planets just hanging out, not directly affiliated with any one star. This isn't enough to solve dark matter, don't at me.
Right.
But it is enough to really allow us to realize there is a vast quantity of small, cold, round stuff moving through our galaxy, that the only way we can possibly see it outside of star forming regions like Orion or Carina, we need to look at Carina more, please, is unfortunately through gravitational lensing events. And so far that I know of, we haven't found any rogue planets that way. So this is a population that was unknown.
We know of 100. We know of about 100 rogue planets through gravitational microlensing.
I stand corrected, because he reads more research papers than I do some weeks.
Right. Yeah. And so this new snapshot of the Orion Nebula, they found hundreds, like more than 500 rogue planets, Jupiter-sized, Saturn-sized, bigger. And many of these, about 9%, are in binary star relationships. And so you've got two rogue Jupiters orbiting one another. And they had hints that this was the case from Spitzer and Herschel, which are, far infrared instruments, but they didn't have this level of detail. And so now they were able to find this. And these are just the big ones. Like, for every rogue Saturn, there's going to be 10 rogue Earths. And so now, like in the past, we would think, maybe there's a couple of rogue planets per system. And now there are probably more rogue planets than stars.
Mm-hmm.
Maybe more rogue planets than planets.
It's
Crazy.
wild. So
Yeah.
So we've really found hundreds using just gravitational lensing?
Nope. We found 100 through gravitational microlensing. Yeah.
Wow. Okay. I clearly am
there's
missing
about
a corner
100
of
known
literature.
rogue planets. Yeah, there's 100 known rogue planets before this new discovery of 540 announced in one paper.
And that's the other side of this story, is it's getting to the point that unless your entire job is keeping track of this, thank you, Fraser.
Yeah. That's all I do.
The stories on the rogue planets in Orion didn't mention the rogue planets that were microlensed in general. And so it's getting hard to keep track of all the different things we're learning in all the different ways. And one of the most powerful tools we have for advancing astronomy is getting people who work in different disciplines in the same room, comparing what they learned in different ways and seeing how that information fits together. And it's getting harder and harder to do that every day.
Yeah. It's funny because I almost sometimes play that role. Like when I'm interviewing somebody, I'm like, oh, what about this paper over there? And like, I hadn't heard about that. And then I send them the paper, because they weren't aware this other team had made this discovery over on that side. It's like, it is really hard. I think this is one of those things that if we had AI telling us things that might be also useful to what we're working on right now, that would be very helpful.
And not hallucinating.
Yeah. All right. We're going to talk about some more stuff in a second, but it's time for another break. And we're back. So we've talked about rogue planets. We've talked about new galaxies, the distant universe. Let's talk a bit about exoplanets.
So we're finally going to start seeing the potential from tests that had been counted on, and JWST was able to confirm its first exoplanet. So for those of you who don't remember the story, the original plan for TESS was it would launch about the same time as JWST. The two of them would be working in coordinated planning the entire time, such that when TESS finds a world in the process of transiting, there'd be the capacity to steer over JWST and go yes or no by looking at the atmosphere. And this is just such a fabulous story. And then TESS got to orbit and is like, I'm here by myself. And TESS did amazing work. Ground-based astronomers have been doing crazy, amazing stuff, figuring out how to get as close as they could to what it was planned for JWST to be doing. But finally, we're there. We're able to do this. And yeah, I'm just sort of like, TESS can do the thing.
Yeah.
And JWST, with its ability to look at atmospheres, has been confirming all sorts of molecules, atoms, things we weren't expecting around planets. Kelt 9b is my favorite. It seems to have every weird hot atom that you can only see under extremely high temperatures, and I'm loving it. What's your favorite?
Well, I mean, just like all of it is my favorite, because prior to JWST, there was a couple of exoplanet observations done with Spitzer poorly. Like it could just barely analyze the atmosphere of a planet that was transiting in front of its star. And so we knew of just a couple of examples. Like, yes, it has an atmosphere, and we think there's like some chemicals in that atmosphere. No more, no more data. But with JWST, it's finding really solid lines of carbon dioxide, carbon monoxide, oxygen, water, sulfur dioxide, all of these chemicals, and then weird ones like quartz, like glass clouds and things like that. And so you're just getting like every planet that they turn on and gather enough data, they map its atmosphere, which like again, we get so used to this, right? That, by the way, there is a telescope that is currently mapping the atmosphere of planets orbiting other stars so that we know what's in them. Now, obviously, we haven't found stuff that makes us think there's life there. The TRAPPIST-1 systems are all coming up airless, but still, it's phenomenal that this happens. And so each one, you see a new paper comes out and you're like, oh, this is so cool. And imagine there will be this day in the future where we will have analyzed thousands, tens of thousands, that we will know sort of at a statistical level what chemicals are in the atmospheres of planets. And this is how it begins. Right now there is maybe 10 that have been done so far, but it's just going to snowball into the future. And so each one is just so great.
And the other side of this is, like, from ALMA, we've gotten amazing details on planetary disks in the process of forming worlds around youngish stars. JWST is taking us a step earlier in some cases and allowing us to see that first breath, that class 0 protostars in disks with light and seeing the structure of the interstellar medium around them. And so we're starting to improve the different kinds of snapshots we have, where we can see the story of, and here is where they turn on, and here's where the worlds form, and here's where, if you have enough stars forming together, they fling worlds everywhere. Space is messy, and we're getting more glimpses of it.
Yeah, and it is, and then, like, sorry, let me say this again. So you've got this situation where you go from nothing, a giant cloud of gas, and then on the other side you've got a star with all of its planets and it's blown everything away. And then there is that moment. And people always ask me that question, like, like how long does it take for a star to ignite? And what do you mean by ignite is sort of the question I always come back with, because it takes some time. But literally you were seeing in that 100,000 years where you go from cold gas cloud to hot knot in the middle with infrared. That's what JWST is perfect for. And so you're seeing these little slices of star formation at different points. At the specific scale, like we see these like Harbig Haro objects.
Yes.
But then at the grandest scales, as you said, the Carina Nebula, the Tarantula Nebula, the Orion Nebula, the Eagle Nebula, like the most dramatic nebulae that we know of, the ones that are on all of our phones, all of our computer backgrounds, we're just looking with like X-ray vision right into these nebulae and seeing all of the stars that are forming that would have just been opaque in a visible light telescope.
And it's wonderful because with JWST, all the things that we're used to seeing with our backyard telescopes that just block the light of what's beyond, we can now start to at least see into with some of these giant molecular clouds and the galactic center brick and all these other structures that we just didn't know that. I mean, we knew they were there. We knew they were full of molecules. We knew they were cold. And now we can see at least a little ways into them and start to understand all the steps using all the wavelengths of light, because we have a new wavelength to explore.
Yeah. There was a paper that came out where astronomers had been put together all of their plans for doing an infrared investigation around the supermassive black hole at the heart of the Milky Way. So 150 hours to study the motions of all of the stars going around the black hole, the gas clouds that are around there, the weird regions of star formation that are way too close to the center of the Milky Way. And so for year 2, there will be even more of these. And when you think about the fact that we'll probably have this telescope for 20 years, it's going to be just year after year after year of these kinds of discoveries and announcements. It's a good time. I remember I said before was the golden age of astronomy. No. We're now in the golden age of astronomy.
No, we still need to get Vera Rubin doing her survey.
And Euclid and Nancy Grace Roman, right?
Yes.
Those 3 instruments working together are going to be just phenomenal. And, we're going to see the first color pictures from Euclid. By the time you listen to this, they will have been released. And we're waiting for that.
It's an impatient time, and some of the most impatient people out there right now are the folks that just in the past couple of weeks have submitted new cycle proposals to JWST saying, this is what we want to see next. And
that was cycle 3, right?
Yes.
Yeah, they had to submit cycle 3. Amazing.
And so now we have the potential to start seeing follow-up observations on the initial images. We get to start seeing, the more telescopes come online, the more follow-up to the more concepts that we have the potential to get to follow up. That was a very awkward sentence for very awesome science.
More follow-up, more better.
Yes.
Pamela, thank you.
Thank you. And thank you so much to all of our patrons out there who get ad-free versions of every episode and make it possible for us to pay our staff who keep us rational and sane. So this week I would like to thank Jordan Young, Stephen Veit, Jeanette Wink, Bore Andro Levsval, Seji Kemmler, Andrew Palestra, Ed, BoogieNet, Brian Cagle, David Trogue, Gerhard Schweitzer, David, Buzz Barsek, Zero Chill, Laura Kettleson, Robert Palesma, Joe Holstein, Richard Drum, Les Howard, Adam Anise Brown, Gordon Dewis, who's in the room with me, Alexis, Wanderer M101, Felix Goot, Kim Barron, Astro Sets, William Andres, Gold, Roland Vormerdam, all of you. Thank you for supporting us at the "we're sorry, Pamela will likely mispronounce your name" level. They don't teach phonics so well in this country.
Is that in Astronomy Cast, like in our Patreon tiers? That should be one of them for sure.
I think we need to rename that tier.
I like it. All right. Thanks, everyone. And we'll see you next week.
And then they saved. All right. So we have a couple minutes left. We just got word that the speaker for the next session had to cancel. And so I'm looking meaningfully at the person in the room and saying, please go look at Discord, because I put an idea in Discord. And we are here to take questions, and we can take our time answering your questions. While that's happening, I'm going to pull up where we are on donations. I just didn't want to be distracted while I was streaming, because Astronomy Cast requires all my brain, all of it. So we are currently sitting at $4,749 in donations and 22,212 bits. So divide by 100 on that. So we are somewhere right around $5,000 combined. We really need to make it to $10,000. All right.
So I don't see any questions. Do you see any questions?
Hold on. I don't see...
Because I have a rant.
Okay, go for your rant, because I'm not seeing anything in Twitch, and you have YouTube.
Yeah, I'm looking at YouTube. I mean, Arjun asked a question. Does it make any sense that binary rogue planets could form from a gas cloud? It seems more likely that binary planets are going to come from ejections from binary stars. But it is weird, right? That you would get two rogue planets orbiting around each other, getting ejected together. What would be the stellar kinematics that would cause such a thing? Or would they have formed in place? Yeah, I don't have any indication either way.
It would have to have been a 3-body problem that became a 2-body problem.
Right. Yeah.
So I'm entirely sure.
Yeah. But yeah, so the issue, and this was, I went on Skylius's show last night after doing CosmoQuest, because I saw that she was also streaming, and I don't know if she rated.
She did.
After she was finished.
Yeah,
good. Okay,
she
good.
Rated.
Yeah. So and we were talking about the science spam crisis on YouTube.
Yes.
Have you been following this? Have you been seeing what's going on YouTube?
I'm a victim of it. There is at least one channel out there that is putting out all of this anti-Pamela gay content. And like I'm paying someone to keep me sane and hide most of it from me, but some of it still comes through, and it's mostly Lawrence Krauss and Neil deGrasse Tyson fanboys that are very anti-me.
So they're making videos about you?
Where they're misclipping me saying things in various speeches and then editorializing on what a terrible human being I am.
That's different. That's awful.
Yeah.
But that's not this issue.
No,
that's just somebody being an asshole and targeting you.
That. Yeah. I also made the mistake of back in 2012 being pro Elon Musk, and now I'm getting a whole lot of hate for that. So it's like, anyways, I will shut up now. Talk about the bad science that's out there coming from AI.
Yeah. So if you do a search on YouTube for just various topics like dark matter, dark energy, JWST, you get a mixture of good videos and stuff that is nonsense and wrong, that is written by artificial intelligence, by some faceless channel at scale where they're producing several new videos a day. It often has like Neil deGrasse Tyson or Brian Cox crying on the thumbnail saying we were wrong. And if you go to like, if you're like not logged in and you go to the YouTube homepage, sometimes these are there on the homepage, and they are creating a generation of kids who are like seeing these videos because they sound very authoritative. They're using clips and B-roll and stuff from documentaries. In some cases, they're outright stealing other people's content. and they are performing well because they have high engagement and YouTube wants to send them traffic. And so Kyle Hill did a terrific video about 6 months ago where he like really clarified the issue. And then the BBC World Service did an episode about this problem. Yeah. So if you search for like YouTube science spam BBC, you'll get their video where they actually showed some of these videos to kids and then asked the kids if they thought this was real science, and the kids totally thought they're and it is like literally like aliens built the pyramids type stuff.
And it's not just YouTube. If you spend any time on Insta or TikTok,
oh, for sure,
there is especially that AI lady voice that, like, anytime I hear that voice, I'm like, this is going to be bad content instantly. And
so there are new, so like you could like write a script. And so what seems to be, what I'm thinking is happening is that somebody is writing a script on ChatGPT or something like that about space that is about 30 minutes long, 45 minutes long. They're just continuing the prompt, and it's just rambles, like and any little part of it is actually fine, but it just doesn't hang together. It has nothing to do with the thumbnail, and it's just, and then they are putting unconnected B-roll to that text. They're getting 11 Labs or something like that to do the narration because it sounds human. And so it is like, if you squint, it looks legit. But then when you watch, you go, wait a minute, right? This is all just nonsense and gibberish. And yet, because they're monetized, they're getting millions of views on individual videos. Like, I wish I got the kind of traffic that some of these videos are getting.
Yeah.
Purely because they are designed to provoke a reaction from people. And it is like, again, like, do this right now. Go to YouTube, search for JWST, and watch what happens. Like you can go through the list and go, oh, nope, that's BS. Nope, that's BS. That's BS.
Yeah.
Like, I wouldn't do this live, but anyone who's watching this can do this for themselves. And you can just see the stuff. Like, usually we'll have Brian Cox or Neil deGrasse Tyson or, some, Michio Kaku, and they're saying, we were wrong. Because clearly, like, that's what people want to hear. They want to hear Neil deGrasse Tyson sob that cosmologists were wrong about the universe, because that's what gets engagement. And yet, if you actually watch the video, it has nothing to do with what, or James Webb has finally seen the true edge of the universe, or James Webb has found life on a planet. This kind of stuff, like, it's just nonsense. And yet they're doing incredibly well. And you're just like, well, look, what are we supposed to do as science creators? How do we keep up with a machine that is providing disinformation at scale? And there is no interest from YouTube to take this seriously. I don't know what the answer is. It's making me mad.
Yeah.
Like I want to organize a walkout of all of the science YouTubers or something. Because
the other side of it that gets me is so I love doing art and painting and illustration and taking the things I paint and turning them so, like, that this part right here is one of my paintings. This over here is one of my paintings. They were brought together in Photoshop, turned into this small solar system, and I love doing stuff like that. And so I follow a lot of Photoshop and Illustrator, Insta accounts to learn things I don't know. And the other day I saw one that just kind of was just like, oh no, because it was this woman in a video who turns and looks at the camera, and she's in like a soccer field with the limes and the industrial complex in the background, and she's dressed beautifully. It's stunning. The skies are blue, the grass is green, and she goes like prancing across it basically. Mm-hmm. And then they go through and they like highlight an area, and they're like, castle, generative AI. Snow-capped mountain, add a tree, add leaves, make it a meadow instead of a soccer field. And suddenly you have this amazing fantasy fake. And luckily AI fails miserably if you ask it to make nebula. It's glorious how badly it can handle star forming regions. But at some point it will get better.
So if people were creating artificial intelligence videos about space and they were correct, I would have no problem with this.
Yes.
Right? Like, it is not about the way this stuff was made. It is about what is the final product and what it is doing to people's understanding of science. So no, when someone masters artificial intelligence and it doesn't make errors and it provides good references and it explains things in a coherent manner and it provides a scientific narrative, then I will seed the field. I will gladly walk off the field and work in my garden.
Yeah.
Right. But the problem is that it is inaccurate. It's misinformation. It's disinformation. It is disingenuous. People are making money from it. YouTube is supporting it. YouTube is providing this platform and is either unable or unwilling to deal with the problem. And it is just continuing to get worse. And right now, you find the stuff that's wrong and you get rid of it. And later on, when you can't tell what's right and what's wrong because it's so good, then it's fine. Right? Like, at that point. And so, even what you're talking about people doing art, AI art is mostly unusable for me.
Yeah.
Like, if I try to I want to show an example of a circumpolar orbiting planetary disk around two stars, it can't do it.
Yeah,
right?
Yeah.
No matter how carefully I describe what I want to see. No. I want a disk of material around both stars, like a donut around two stars. I get a donut, right? So, but if I want to, show a Dyson sphere, no problem. It can do Dyson spheres all day long.
Yeah, it's
right.
So
it's fine. I don't have a problem with that.
The most fabulous fail that I have encountered of things I did not expect to fail were for our Hangout-a-Thon, since it's basically, we refer to it as the HAT, Hangout-a-Thon. We wanted to do Pass the Hat for Science, and I was trying to do graphics for that, and I could not find any combination of words that would draw a top hat sitting opening upwards.
Right.
Top
hat
upside down did not get me anything useful.
Yeah.
Top hat sitting on sidewalk collecting money. Hat in front of busker collecting money. None of these things
worked.
Yeah. So
that's funny. Yeah.
So we don't seem to have someone over in Minecraft right now to go show off our Minecraft world. And the person I would ask to do it is filling in on the next panel. So we're in a bit of a hard place. Any of you out there who are expecting to see Minecraft, come back in 1 hour and we will fill your needs. So I'm actually going to have to say goodbye to you, Fraser. I'm going to hand things over to my producer so I can run away and come back for the next panel. Thank you.
Well, good luck for the rest of your Hangout-a-Thon, and everybody who's watching this. Don't forget to support all of the incredible work that's being done at CosmoQuest. Thanks to you, we are able to hire people to do science, to help make the world a better place, to spread more scientific information, try to fight misinformation, disinformation, and find landing sites for spacecraft.
Yeah, it's amazing.
All right,
Thank
thanks,
you.
everyone.
Okay, bye-bye, Fraser. And I'm finding the button. I'm clicking the button. Clicking the other button.